Good afternoon. Time for another worked example from first principles. If f of x is x squared plus 5x plus 4, find f dash x and then f dash x equals 0. So first things first. First principles. The formula is f dash x equals limit as h approaches 0. F of x plus h minus f of x over h. So first things first, we need to find f of x plus h so that we can write it in. So f of x plus h equals x plus h squared plus so it equals that. We now need to expand all of that. That expands to x squared plus 2xh plus h squared plus 5x plus 5h plus 4. Now we write out our formula again. So f of x plus h, we now know what that is. That's x squared plus 2xh plus h squared plus 5x plus 5h plus 4. Then we subtract all of x squared plus 5x plus 4, which means we're doing negatives. So it's going to be x squared minus that x squared. So they'll go away. This 5x minus this 5x. This plus 4 and that plus 4. They go away. And of course, this whole time, everything was over h and my limit statement was still there. All right, that limit statement doesn't go anywhere until the very, very end. The last thing you do is get rid of the limit, is to do the limit thing. So now that we've counted all this stuff down, let's just tinker with this a little bit. H approaches 0. So what have I got? I've got 2xh plus h squared plus 5h all over h. Because if you go back up to the original formula, it's minus f of x. All right? It's minus f of x. So I'm taking away everything that's in f of x. And the way that I remind myself that I have to start doing some negative stuff is by putting the original statement inside brackets. Because what a lot of people would do is they would not put in brackets and then they would go, oh, it's x squared minus x squared, but then 5x plus 5x. And 4 plus 4. They wouldn't actually subtract the 5x and the 4. They would only subtract the x squared. And that obviously results in a completely different answer and it's completely wrong. So by putting the negative in there, I'm reminding myself that I have to do a negative of everything going on there. So back to where I was. I have a h here, a h here, and a h here. I can factorize the top. h 2x plus h squared plus 5 all over h. What happens to the h's? They cancel down. So I'm left with the final, or second last step of 2x plus h. That's gone. Plus 5. Now I say h equals 0. And my final answer, my end goal was f dash x equals 2x plus 5. So now for any point on my original statement of f of x, I have this derivative equation. And this derivative equation can be used to describe the turning point, describe the gradient at any point along that line. And I let slip it before. The turning point happens to be an interesting point because the gradient at a turning point or an inflection point on a cubic is always 0. So if I was asking you f dash x equals 0, find x, what I'm actually asking you for is, where is the turning point? Where is the gradient equal to 0? And in this case here, 0 equals 2x plus 5. Solve that, minus 5 over 2 equals x, which was said in the chat before I started doing all this. So what I've done is I've shown you how to find the turning point by hand. Not using any weird and wonderful rules, because I mean, we could go back. What happened to the h? So here, 2x plus h plus 5. So when I get to this point here, where I just have that one h by itself, what I do is that's when I start squeezing that gap. The distance between any 2 points is so infinitesimally small, I just say it's 0. So I say it's 0, it goes away. So for any point on the original quadratic, because that's what it was x squared plus 5x plus 4, that describes where everything is. That describes the gradient at any point along there. Yes, but not for unit 1 and 2 math methods. The question was, can it be any number other than 0? Yes, you could play around with it and have certain limits. For example, you might have a minimum value that you can't go below if you're talking about a practical application. But for straight, bog standard calculus like this, using first principles, h is 0. You will play with limits some more in units 3 and 4. So if we go back up to our original question here, there's a formula that I taught you guys all those years ago. Formula I taught you all those months ago. It feels like years, hasn't it? All those months ago, for finding the turning point, or finding the x value of the turning point, the axis of symmetry. And that was x equals negative b over 2a. Well, if I look here, b is 5, a is 1, so x equals negative b over 2a, which is 5 over 2. Which is what I got before. All right, and we get this equation from calculus. When I showed you that all those months ago, what I was actually showing you was a sneak peek into calculus, because that is where we get that equation from. Why do all that work when you can just use that equation? Okay, cool. Problem is that up there only works on quadratics. Also, yeah, because it's methods, and I want to torture you. The problem is what about when I start going into things that are a little bit more complicated? What about when I start asking you about cubics? When I want to know the equation that describes a cubic. All right, so let me just pull up let me just create an equation I think is going to be interesting. Let's go. Can I have a number between 1 and 5, please? Can I have a number between 1 and 4? And I've got a 2, and I've got a 2 on the end. Cool. Thank you. So before, when we were experimenting with cubics earlier in the year, I was asking you to find the turning points using your CAS. Well, now is the time to start thinking about how to do these things by hand. Oh, yuck. If f of x is equal to x cubed plus 3x squared minus 10x minus 24, find f dash x and then the turning points. And this is why we can't just use that formula for everything, because we have more complicated questions like this. All right. So, correct, but first principles. You're using the forbidden knowledge. Do not use the forbidden knowledge. So we've got f of x plus h. That's going to be x plus h squared plus 3x plus h cubed minus 10x plus h minus 24. Now, x plus h cubed expands to x cubed plus 3x squared h plus 3x h squared plus h cubed plus 3 bracket x squared plus 2xh plus h squared minus 10x minus 10h minus 24. Expand that out to 3x squared plus 6xh plus 3h squared So that is just f of x plus h. Now, to make my life a little easier so I'm not constantly rewriting it, I have to remember what the formula is. I subtract f of x. So I go back up here and I find anything that is up here and get rid of it down here. So there's an x cubed up here, well, it goes away. There's a 3x squared up there, it goes away. There's a 10x, it goes away. There's a 24, it goes away. Now, everything else is all divided by h. So that means I've got a 3x squared h plus 3x h squared plus h cubed plus 6x h plus 3h squared minus 10h. All over h, of course. From there, I can factorize out the original h. and start cancelling out. What I've got. And that leaves me with 3x squared plus 3xh plus h squared plus 6x plus 3h minus 10. And this whole time, remember that the limit h approaches 0 is still down the side. It hasn't gone away, I'm just not writing it all the time. Now that I've gotten to this point here, where I only have h's, now is when I can go, okay, cool, my gap is now so small that it might as well be 0, so I'm going to say it's 0. That means this becomes 0, this becomes 0, and this becomes 0, and I'm left with 3x squared plus 6x minus 10. Now that I have that, so f dash x equals 3x squared plus 6x minus 10. F dash x equals 0. I now need to figure out 0 equals 3x squared plus 6x minus 10. I need to solve that. All right. I don't care about factorizing it. I don't need to simplify it. I just want the answer. All right. How do I find that answer?
Quadratic equation.
Thank you. Thank you. Can you use the equation? Yeah, you'll need to be more specific than that. You can use the equation. And that equation is the quadratic formula. X equals negative b plus minus the square root of delta divided by 2a. And delta is, of course, b squared minus 4ac. So in this case, I've got a, b, and then that whole thing is c. So delta 36 minus 4 times 3 times minus 10. So that's delta of 156. 4 times 3 is 12, times 10 is 120, minus times a minus is a plus. 36 plus 120 is 156. So now I can go back to my equation. X equals negative b, which is 6. Negative 6 plus minus the square root of 156, all divided by 2a, which is, and then your answer should come out to be negative 1 plus minus the square root of 39 over 3. For those of you that have forgotten your surds, 156 is the square root of 4 times 39. Square root of 4, so that's the square root of 4 times the square root of 39. That's 2 root 39. The 6's cancel down to -1. The 2 and the 6 cancel down to over 3. So therefore, you now have the exact location for the x values of your turning points. So that x equals 1 plus or minus the square root of 39 over 3. So f dash x is 0 when x is that. And then you could sub those into the original equation to get the other value. So then you would sub into just normal f of x to get the y value for the turning points. So TPY. All right, your work today. 17A, question 12. There's about 6 in there. I want you to do them on paper. I want you to scan them and I want you to send them to me. All right, just question 12. Do question 12, send it to me, and it's all good.